Hi, grade 3 teachers. Let's have a look at some ways that you can connect computer sciences into your living systems unit. So your computer sciences curriculum talks about creativity and its relationship to computational thinking. And there are some great ways that you can connect this creativity and computational thinking into your living systems, as well as into your other daily classroom routines and activities. We have a number of understandings in the computer sciences, and we're starting to see students learning about writing two different sets of instructions to achieve the same outcome. We're here to see about some engineering, they're look at Canadian invention. So some of these won't tie specifically into things other than computer science, but there's some great ways that you can connect them into the living systems unit as well. Creativity, whether we're talking about computer sciences or projects that we're doing or activities, lessons, or just life in general, being able to find different ways to reach a different outcome is a really good skill for everyone to learn. And it's a key learning in the computer sciences curriculum all the way from kindergarten through grade 6. To be a good problem solver, you have to be able to look at a situation in a different way. You might have to figure out a new way to use something old or find a different way to get somewhere because the way that you were going to get there before has somehow been blocked. So creativity in the science is really just about using those problem solving skills and thinking creatively about ways to reach an outcome in different ways. We see the design thinking process popping up all the way through the curriculum from kindergarten to grade 6 as well. We'll look at some ways that design thinking comes up for you and that we can connect this into your living systems unit. And of course, we'll also talk about how the computational thinking can be connected in, because this is the other third key piece of that computer sciences curriculum all the way through the elementary grades. When we start to look into your specific living systems curriculum, whether we're looking at this skill and procedure or one of the others, some key things are going to ride all of the way through. So in the science outcomes, we see a lot of classifying, comparing. We're going to be grouping and sorting animals and objects and materials and substances. And throughout the grades all the way from kindergarten up and across the units, we see a lot in science of the classifying and sorting, etc. So when we are taking something, it can be an object. In this case, we're talking about animals and classifying them in a food chain. We are going to start talking about carnivores, herbivores, or omnivores now in grade 3. So we are going to be looking at animals for specific traits that define them as these three things. When we're looking at a specific trait, we are doing that decomposition piece. If all I care about is what an animal eats, it really doesn't matter if it walks on 4 legs or 2 legs. The only thing that matters is what it eats. So I'm decomposing and looking for what attribute in this animal am I looking for to meet this objective, which in this case is where does it belong on the food chain. By recognizing what things might be attributes of animals that make up these 3 categories, we can start to move into recognizing patterns, such as carnivores have sharp teeth for tearing meat, or omnivores have flat teeth for grinding up plants. So we can see those patterns, we can talk about them with our students, and just while we're doing this skill and procedure in science, we can just talk about recognizing the patterns, talk about what attributes we're looking at, and now we're also covering this computational thinking pieces. And if we start to take what we've discovered about the animals that we're looking at, and we start to look for other animals and how we can classify them or come up with rules for how we can classify animals, we're moving into abstraction. We've taken everything apart. We've found the specific items that are going to achieve us our outcome in classifying these animals, and now we're at this level of abstraction. In the kindergarten through grade 2 science curriculums, they're talking they start out very basic about following and ordering simple sets of instructions. This gets more complicated by grade 2. They're asked to find mistakes in a set of instructions and fix the mistakes to make the instructions accurate. So at your grade level, you're needing to sort of bridge those gaps. Anytime during the day that you can connect into those instruction following pieces for the students, you're going to help bridge up those gaps in computer sciences. So with the elementary kids, I often encourage teachers to explain to students how coding or giving a machine or a computer a set of instruction is very much the same as me as your teacher giving you instructions. On the first day of school, I turned you guys into my little robots when you walked in, and I told you what I wanted you to do every morning when you came into my class. That was the very first algorithm I ever taught you. So you use this sort of language and frame them up that the instructions that you give them in class, whether it be instructions for an assignment or an activity, or instructions for what they're supposed to do before school tomorrow, or what they need to bring back in 2 weeks. Anything that we're doing inside the classroom could be set up in that frame that you're my robots. What's our starting condition? What's our event? What's going to set off this algorithm? Oh, when the bell rings. And what happens when the bell rings? We take off our shoes, put them on our chair, go to our locker, get our coat, etc., etc. So just working those algorithms and using that language, you can embed the computer sciences piece into everything you're doing. So even just this instruction for determine these animals and how they should be classified, we're going to be covering this stuff in a sort of non-specific way, non-explicit way. We can also cover it explicitly when we get into the actual activity. So when we start looking at the attributes in what classifies these animals, and we're talking about what is all the same for animals that are carnivores and what is different based on what they eat, and we might decide that there are some similarities and differences, and this is breaking these things down into what we're looking at. And in this case, we're looking at just what they eat. So we've decomposed it out. We have a variety of different kinds of animals, but we can be sure that what is the same is that they eat from the same sort of food group. They're carnivores, herbivores, or maybe they eat both. We might talk about what is different based on what they eat. Then as we're looking at continuing to analyze these groups and what traits do all carnivores have in common, like the sharp teeth I mentioned, we can talk about how omnivores are different and the same from the others and start to recognize those patterns that exist within and between our classifications. And then we could ask students, how many more carnivores can you find? How many more omnivores can you find? Where do humans fit into this description? And we might have further discussion on that too. Are all humans in all of these places? Is a carnivore, is it based on what you do eat or what you can eat? Maybe that's a larger question too. So now we're applying what we've been discussing, applying what we know about the animals that we first started with into new situations, new things, looking at those rules that we've come up with and applying what is specific, just what we eat. We can apply that to any animal. We can abstract it anywhere. We can take this to that last step with computational thinking. Again, going back to KidBots, using the algorithm language with students all the time. Can you write a rule? So we've talked lots about sets of instructions. We can also use rules as a reference to algorithms, coding design. So how can we write a rule to tell if an animal is a carnivore, omnivore, etc.? And then here at the bottom we can see if it's only eats meat, then it's a carnivore. So we don't have to have students writing these things down. This isn't an activity that has to be assessed for computer science. This is just a way to incorporate it into a living system lesson in a way that will help kids connect, so that when you are explicitly teaching this, you are explicitly assessing these things. You've given the student a variety of ways to learn and understand. We're going to ask students to build or represent food chains in different ways. We can definitely work again through that computational thinking with them as we're doing that. So if we have a look at a couple of different food chains as we're beginning to introduce this, and we're having conversations about what do we know about the things in these food chains, what do we notice about how they start and how they end, and we can start to sort of break down what we see here and decompose, well, what's at the beginning, what are the traits of the things that are at the beginning of a food chain. And do we know some classifications for this already from things that we've learned in science before? And then we can talk about how maybe we discuss that, one is on land and one is in water, and there's a difference. And then we can discuss what is the same about these guys that are on this far end of the food chain, and what do you think that means at this end. And so now we're just looking at the different traits again and breaking these down, making some connections to learning that we already have. We can look at similarities between the two food chains, look at differences between them, recognize where the patterns are the same, recognize where patterns might be different, and see that there is something that is the same no matter what's in between the arrows. There is some connection. There is a rule that has to be followed in order for a food chain to be in the correct order. And now that we have had some discussion and we've looked at some example food chains and we've talked about the attributes of the animals that we see in the different places on the food chain, we can ask students, based on what you know, do you think you can put this food chain in order now? And we can think about, well, we remember that there was plants. Plants are always at this end, and how we're going to start. And what is our rule for putting things in order? Well, if it eats, it goes the next in the chain. So students can take what they've learned about the food chains already. They can create a food chain, which in itself is a type of algorithm. So we are creating a set of instructions that could be followed by a human or a machine to complete a task, essentially putting this food chain in order. You could ask students to write or tell you how to put that in order, and they would be even going to that extra level of creating that sort of computer or machine set of instructions. So those are some ways that you can tie those computer science outcomes into your living systems fairly easily without extra work. Just making those extra connections to that computer science stuff all of the time is going to help your students get a really solid understanding of that as they move up into the further grades and have to cover the outcomes that are coming there too.